Now before watching this video, you should first watch video number 1 of this playlist, in which we have discussed what are tangents, secants and their properties. How many tangents can a circle have? We see here 4 tangents are already drawn to the circle. So are these all what we can draw, or we can draw more? Let us try. Any more? Yes. So how many can we draw? We can draw infinitely many tangents to a circle, as we can get an idea from this figure. Question number 2. A tangent to a circle intercepts it in one point. In figure, we see line T intersects the circle at one point P. It is tangent to the circle. A line intersecting circle in 2 points is called secant. In figure, AB intersects circle at points A and B. That is 2 points. Therefore, it is secant. A circle can have dash parallel tangents at the most. Here in figure we see 2 parallel tangents are drawn to the circle. Can we draw more? Let us try. Is this a tangent? No. It intersects the circle at 2 points. Therefore, it is a secant. So the maximum is 2. A circle can have 2 parallel tangents at the most. So this is not a tangent. The common point of a tangent to a circle and the circle is called point of contact. Now once what we have done in this exercise up to now, how many tangents can a circle have? Infinitely many. A tangent to a circle intercepts it in one point. A line intersecting circle in 2 points is called secant. A circle can have 2 parallel tangents at the most. The common point of a tangent to a circle and the circle is called point of contact. Question 3. A tangent PQ at a point P of a circle, of radius 5 centimeter. Radius of circle is 5 centimeter. Meets a line through the center at O. Meets a line through the center O, and this length is given as 12 centimeter. We have to find out the length of the tangent PQ. Now angle 1 is equal to 90 degree. Why angle 1 is equal to 90 degree? We have done in the first video of this series, of this playlist, that the tangent is perpendicular to radius at point of contact. Now in right triangle QPO, because angle 1 is 90, so this triangle becomes a right triangle. We have OQ square is equal to OP square plus PQ square. Why this relation? This is by Pythagoras theorem. This theorem states that in a right triangle, square of hypotenuse is equal to sum of squares of remaining two sides. Which side is hypotenuse here? Side opposite to 90 degree is hypotenuse, so OQ is hypotenuse. So we get OQ square is equal to OP square plus PQ square. Now put the given values. After putting the given values, we get 12 square is equal to 5 square plus PQ square. Transposing, we get PQ is equal to square root of 119 centimeter. So what was given here? Tangent PQ, radius 5, distance between the external point and center 12, angle 190, angle between radius and tangent at point of contact. Using Pythagoras theorem, we get PQ is equal to square root of 119 centimeter. Question 4. Draw a circle. We draw a circle with center O. That is our first step. And two lines parallel to a given line. But question is, where is this given line? Such that one is tangent and other is secant to the circle. We will draw tangent and secant, but first we need this given line. For that, we have draw secant L passing through O. We have drawn this line L passing through O, the center of circle. Now, why are we passing it through O? Because we want to use property of tangent, that tangent is perpendicular to radius at point of contact. So, third step is draw M perpendicular to L at A point on L. Anywhere take a point on L and draw perpendicular. Now M is perpendicular to L. Now comes tangent and secant. Because the tangent intersects the circle at one point, we draw at B a perpendicular to L. Now next, take a point C on L in the interior of circle and draw a line perpendicular to L again. Now we say that T is tangent and S is secant. But is it tangent? Let us check out. We see T intersects the circle at a point. T intersects the circle at a point. Therefore, it is tangent to circle. Now, what about S? S intersects circle at 2 points. Which 2 points? M and N. Therefore, S is secant to the circle. Now we have proved that T and S are tangent and secant. But we have also to prove they are parallel to line M. Because M is perpendicular to L, so angle 1 is 90. T is perpendicular to L, angle 2 is 90. S is perpendicular to L, angle 3 is 90. Now, angle 1 is equal to 2. What type of angles are these? These are corresponding angles. Therefore, T is parallel to M. Since 1 and 2 are corresponding angles. We know if corresponding angles are equal, then lines are parallel. Then again, angle 1 is equal to angle 3. But these are again corresponding angles. Therefore, S is parallel to M. So now we have proved that T and S are tangents and also they are parallel to the given line M, which completes our question and exercise.